Okay, lesson 7 for video 2 here. So let's take a look at the next question. So it says, Alani is in charge of marketing for a travel company. She is designing a brochure that will have 6 photos. The photos can be arranged on the page in a number of ways. So here are those 6 photos. There are 2 main square photos, which have a length of X inches on each side, and then there are 4 narrower photos, rectangles, that are 1 inch by X inch. What is the total area of these photos? So let's take a look here, all right? So let's label this square X by X, and this square X by X. And then the 1 for these rectangles is going to be the short side, and then again, each of them has an X on the vertical side, the whatever. And then same thing here, 1 and X and X. So what we can do here is we could look at the individual areas, or we could look at them all together. So let's do a little bit of both, right? So first off, right, area of a square is side length squared. Area of a rectangle is base times height, or length times width, right? Okay, so we have 2 squares and we have 4 rectangles. So our area total is going to be 2 area of the squares, and each side is x, so 2x squared. This is the area of the square, plus 4 areas of the rectangles, and that would be 1 times x, because those are the dimensions. Okay, so this is going to simplify to 2x squared plus, and then we just multiply. 4 times 1 times x is 4x. And this would be area in inches squared, right? So this would be your total area. Now, if we were to smush these pictures all together, we could come up with an overall dimension there and an overall dimension there, right? So the top is x, 1 and 1, that's x plus 2. The side here is x plus x, which is 2x. So to find the total area, we could also do 2x times x plus 2. And we could distribute this monomial into that binomial. 2x times x is 2x squared. 2x times 2 is positive 4x. And notice you get the same exact answer, just done in a different way. Okay, so we're going to continue using this problem as we go through. Okay, so next it says, all right, so same thing, right? So now it says find a rectangular arrangement for the photos. What factoring represents the arrangement? So now what we're going to do is we're going to rearrange this. This is more like it's not a square technically, but it looks more square. So what if we take all the pictures and put them all next to each other like this? So we put the 2 squares here, and then the 4 rectangles here. So this is a rectangular arrangement, right? So each square has a dimension of x by x. So we know that the height of this rectangular region, the overall rectangular region, is going to be x. But what is going to be the length of the overall rectangular region? Well, that's where you have to look at the individual dimensions, right? So this square has a width of x, or a base of x. So does this one. And all of these rectangles have bases of 1. So the overall rectangular dimension, or dimension of this overall rectangular shape, is 2x's plus 4. So now, to find the area in the factored form, they just want you to multiply the x by 2x plus 4. There's the factored form. And again, all we're doing is playing with different representations of the same problem. Okay, great. Next, it says, okay, now factor out the GCF from the polynomial. What does the GCF represent in the situation? So what we're trying to do here is we're trying to go back to that first problem. So part A, where the total area was 2x squared plus 4x. And they want us to factor out the GCF. So again, if you look at the big numbers, I believe we can take out a 2. So our GCF is going to involve a 2. And you take out the biggest number of x's that they both have, right? Which would be x to the first. This is your GCF. So then if we factor it, we're going to pull out the 2x. And in the parenthesis, right, 2 divided by 2, the 2 is going to go away. Take away an x, that leaves you with x. And then 4 divided by 2 is 2, and this x goes away. There. And again, if you think back to the original problem, right, where we had this factored form is going to be the 2x's here along this side, which would be the height of the arrangement. So x inches. And the x plus 2 would be the top, which is x 1 and 1, x plus 2, which would be the base or the width of the arrangement. I'll call it the base. X plus 2 inches. So again, understand that when we are doing these factoring, right, it's just multiplication and division. That's all it is. That's all it is. Okay. All right, and then last but not least, right, it says, okay, here's your two arrangements, right? We talked about it. Which of these is more practical to use? It says more practical to use on a page of the brochure. Okay, so we're looking for the answer involving practicality. So if you take a look here, right, when you go to a store and pick up a brochure, are they long and skinny like this, or are they more square like that, right? This looks more like a brochure. So I'm going to assume that this arrangement, right? So I'm going to just write out the arrangement with dimensions. And again, you could put this in your own words, with dimensions of 2x inches, which would be this, and x plus 2 inches, which would be this, is more practical and we could say the other arrangement is probably too long for one page. And there you go, right? So again, just in your own words, why this arrangement is better. But understand that there are multiple ways to arrange this, right? You get the same area, the same use of pictures, just one is better than the other. Sure. Perfect. So GCFs, right? Hopefully you understand how to do that, and we'll get to it in class. All right, thanks for watching. See you in class.